Now this meeting also recorded for who missed or you want to see one more time the topic. So today we are going to start fourth unit of part. Okay, part B. So that is nothing but pointers. So why pointers are great? So always pointers are great in any programming language because their dynamic approach. So due to their dynamic approach only pointers are great. So here the dynamicism, how it is going to work. So every computer has addressable memory locations. So we know previously lot of times I drawn this thing. So for suppose there is a 16-bit computer, a 16-bit microcontroller or microprocessor or microcomputer. So this must and should contain 16-bit means what? 2 to the power of 16 addresses are possible. So because of 16-bit address bus, so it is consisting 2 to
Sir,
the power of 16. Yes. Tell me. Tell me.
sir, మీ వాయిస్ వినబడట్లేదు సార్.
Okay, my voice is not. Hello. For everyone or for only one person? My voice. Can anyone respond? Are you able to hear my voice? Hello. If you are unable to speak, chat box. In chat box also you can type. Are you audible? Are you able to hear my voice or not? Hello. Hello. Yeah, are you able to
Yes,
hear
sir,
my
now it
voice?
is audible.
Okay.
Yes, sir.
Okay. So today we are going to start about the lesson pointers. This is half of the part of your fourth unit. Now 1.5 hour class I want to take. Actually it is 11:15. So up to 1 o'clock I want to complete this thing. So what is the exact thing related to pointers? So pointers are derived data types according to our data types. We have fundamental data type and derived data type and user defined data type. So in these things, so the first one, fundamental data types, first unit we covered, and after that we studied about arrays, we studied about functions, we studied about strings, and we are at the phase of pointers. So if you want to understand a pointer, must and should you need to understand the memory concept. So this is a memory. So this memory, for suppose you have a 16-bit device system or 16-bit computer or 16-bit microcontroller, something, because our C program is worked on certain machine. So that machine must and should have address bus. So how many bits at a time it can access? So maybe it is a 16-bit, the total addresses are possible 2 to the power of 16. So 2 to the power of 16 means 0, 0, 0, 0 to, so F, 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 F. So here each F means 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 and 1, 1, 1, 1 in hexadecimal format. So each 0 means 0, 0, 0, 0, 0, 0, 0, 0 and 0, 0, 0, 0. So 0, 0, 0, 0. So this is hexadecimal because 16 bits represented in this format. So the permutations and combinations, so these are the possibilities of addresses. So maybe it is a 16-bit you assume. Maybe your laptop is 64-bit. Some things are 32. Someone is 15. Someone is 8. So depends upon the person to person, system to system, it is changing. But I am talking about general thing. So the general addresses are 0 to 65,535. So total how many? 2 to the power of 16 means 65,536. So these many addresses are possible. These many address locations are possible to access. So these are the locations we can write our program. For suppose if you are declare a, always you are declaring int a is equal to 5. What is the meaning of this thing? Int a is equal to 5. So a is a name of your memory location. Maybe 5 is the data inside of the memory location. So this is 5 and the name of that memory location is a, and this must and should have certain address, maybe 46,328. This is the address because this is the range of 0 to 65,535. So in between these two only it is must and should. So the address is this one. Okay, always we are writing ampersand of a. Ampersand a means what here? This is the address. So we are talking about two things. One is content, one is address. Always we are talking about two things. One is content, one is address. This is the name. This is the name. So right now we want to talk about this thing. Okay. So we want to talk about these addresses and everything. So that is only the pointer. Pointer means dynamic memory allocation purpose you can use. So every computer has addressable memory locations. These only. So what we are talking, that thing. So the data manipulation so far we did with the help of various names, identifiers. So we call it as a identifier: A, B, C, average, area. Okay. So perimeter. So sum, result. So like this we did. We assigned an identifier to data location and manipulated the content with the help of it. Okay, that is possible. Previously we did all programs like that only. So pointer have many uses in C. So they are one of the efficient way of accessing the data for manipulations. So it is a very easiest one and efficient way. And the second one, they also provide efficient techniques for manipulating data in arrays. If you want to use arrays with pointers, that is very easy. And they are used to in functions as pass by address parameter. So call by value, call by address, in that pass by address mechanism you can use. So they are the basics of dynamic allocation of memory. So these are the basics for dynamic memory allocation. Previous one all are static memory allocations only, but pointers are dynamic memory allocation. So next, so introduction. What is a pointer? A pointer is a content or variable or constant. Sometimes it is a constant, sometimes it is a variable that contains an address. So pointer always contains an address that can be used to access data. So it is mainly used to access the data. So pointers are built on the basics of pointer constants. Always we are going to use pointer constants. So what is pointer constant? So first we will see. So some memory location. So there is a G. G is nothing but it is a character. So what is the address? Maybe it is a 32-bit machine. In this 32-bit machine, the address content is 145600. That is the address of that location. And Z is nothing but variable, and the content is nothing but value inside, and a char. So variable name is a char. So I am taking a character. So that is the variable name, and this one, this location, what you call variable, and G is nothing but content or value. Okay, then this is the address. So where it is in the form of a character constants. These all are character constants. So backslash n, a, g, x, something. You have lot of memory. This is a piece of memory I am taking. So if you talk about one piece of memory, so that is nothing but a variable. It is represented with all these parameters. So next, character constants and variables. See, if you talk about this thing, character constant backslash n. So variable name a char, and this is located in 1,45,600 location, and these all are the remaining pointer constants. So these are the pointer constant in the heap memory. This is entire memory. So 00002. So something. So 10,48,000 575. So up to that memory is available. So these are called pointer constants. What you are using and what locations we are using, they are called pointer constants. So being existed in the computer. So what is the pointer constant means? A pointer constant is an address value that specifically represented on a memory location in the computer or main memory. So like every other constant in the computer, a computer world, a character constant cannot be changed. So always character, for suppose A cannot be changed. A is always A. So next, every time a program runs, all variables in the program will get different addresses. So always, so sometime, so today it will take this address. So tomorrow it will take another address. So day after tomorrow it will take another address. So whenever you run that program, depends upon the availability of memory, it will take certain memory location. Always it doesn't take same thing. So this is because in a computer, modern operating system can put a program in memory, okay, wherever it feels convenient. So pointer constants are drawn from a set of address of a computer. So they exist during the runtime of a computer, and we cannot change them, but we can only use them. So that means the addresses are assigned. Today some addresses are assigned, tomorrow they are maybe changed. Okay, we don't know. So compulsory maximum times they are going to be changed, but we can use them. We can read them. So being existed in the computer, a pointer constant can be retrieved and saved inside a variable. Always it can be saved inside a variable. So the address operator, here always we can use ampersand, address operator, extract the address of the variable. So syntax, address variable name. Always we are talking about address variable name. To print the address of a variable, the conversion code %p can be used. Previously what we used? Previously always we can use %d. So if it is an integer, we can use %d. So we will see this thing. This piece of code we will run and we will see. So what happened to this computer? So this is the program, simple program. So we are taking A, B, these are the two variables. So system, okay, CLS, so this is not required for us. CLR, SCR, we can write directly CLR, SCR. So this is not applicable here. So printf %p, %b, address of A, address of B. So what is the meaning of that thing? So for suppose if you write printf, previously you know this thing only, %c, comma, %c. So %c, comma, %c, comma, so A, comma, B. So maybe here A is equal to, I assigned a variable U, capital U, and B is equal to, I assigned a variable some T. Okay, I am assigning like this. This is also possible. So now if I want to see the addresses, these are called addresses. Addresses of A and B variables. Okay, so what happened to address of A and B variables? See here the values, the contents A and B. The contents of A and B, here first we are checking, and later we are checking about the addresses of A and B. So what is the main difference between them? So if you work with this example, so printf /0, so this one. So if you run this program, what happened? So get ch, so the get ch is not required. So the contents of A and B, U, comma, T, we know that thing. So then the addresses of A and B. See, so these are the addresses. The contents are A and B is nothing but U and T. The address of A and B variables is nothing but 0x, because it is a 64-bit machine. This one is 64-bit machine, 128-bit machines we are using nowadays. Because we are using online compiler, so it may be 128-bit. Okay, so due to 128-bit or 12-bit, so 100-bit, so like that, depends upon the thing, the address is going to be changed. So see, conjugative locations it will take. So it is 26. Next one byte, because always constant will take 1 byte. So 27th location is B. Okay, something 26 location is A, something 27 location is B. Both are consecutive locations. So we have address as well as data. So always we are doing this logic only. So in previous all examples also, you don't know what is the pointer, but we are using all the time pointers. Okay, so now these are called pointer constants. So they are constant, so they are not going to be changed. So next, pointer variable. A pointer constant can be saved in a pointer variable and later can be used to access the value. So the type of a pointer must be specific to the type of the variable to which it is going to point. So now where the pointer is going to point. So this is an integer type of variable address. Okay, so it must and should be certain address, this address. So that address must and should be specific and saved into integer type of pointer. So store the address of a variable, we need to special type of variable, that is called pointer variable. So a single variable address can be saved into multiple pointers. Okay, only one address we can store in several pointers also, that is also possible. So that we can't, we will move more number of pointers pointing to the same location, and it is possible in C. So that is possible. So for suppose if you want to point only one address, so number of pointers you can assign. So if a pointer variable not pointing to anywhere, that if it is want to make sure that the pointer is not pointing to any address, that means what? Null pointer. C provides a special called null. So nothing, it is not pointing to any other. So that one we call null pointer. So in the standard input output std.h header file. So for this purpose, okay, always if you include std.h, null pointer is there with you. If you want, you can use. So next, accessing variables through pointers. How to access? How to access the variables through pointers? So here always we are using a point operator called star. So this can be used to, this is asterisk. The star is nothing but asterisk symbol. So it can be used to dereference the pointer. So reference is nothing but address, dereference is nothing but star. Dereference pointer or indirection operator. So the indirection operator is unary operator. This is a unary operator. So whose operand must be a pointer value? Must and should, it is a pointer value. The result is pointed variable value that can be used to find the inception or manipulation. So how to use this thing? See. So a plus plus, we can write a plus plus, or a is equal to a plus 1. So then here star p is equal to star p plus 1 or star p plus plus. We can use star p plus plus. So we will write. So if you write that code, what happened? We will see. So one program we will write. So then what it is going to do. So these are very important, sir. I hope you are writing these examples. So maybe in that material I don't want to provide you. Hash include, this is the first program by using pointers I am writing. stdio.h. So first I want to int main. So here I am going to declare M3 pass అయిపోయారు. Very good. Excellent. Congrats. జాబ్ కూడా వచ్చింది. int num1, maybe n1 is nothing but my pointer, and we are giving n1 is equal to 90. So what is this thing n1 means here? N1 is nothing but it is an integer variable. Okay, it is an identifier, n1, number 1 or n1. So previously we wrote like this only. So now printf percentile d. Okay, printf percentile d. So the value of n1 or the content of n1 is equal to percentile d. If you write address of normal n1, if you write n1, automatically it will print n1. The value of n1 is nothing but what? 90, because we stored 90 only in that program. So backslash n. So the value of n1 is nothing but 90. This one very well known for you. So if you scan, or if you assigned, or if you add something, so must and should be this variable, the content is nothing but 90. So we know that thing. So if you execute this program, so the value of n1 is nothing but 90. So return 0. Okay. So this is printed. So now I want to print about the address. Printf. So backslash n. So the address. So how to print the address? So for suppose if I write percentile d, comma, okay, here address of n1. So integer value of address I am printing right now. See, the address of n1. So nothing, there is no pointer I declared, nothing is declared here, just I am giving. So it must and should be. So the value, no point I am doing, so simply I am doing. So the value of n1 is equal to 90, the address of n1 is equal to some value it is showing. So because it is integers are not suitable to represent that value, that's why it is showing more number. Okay, so here generally what is the thing we need to print? Percentile p. So if you write percentile p here, that will print in hexadecimal format. So if you write percentile x, so that is printed in the normal notation, so positive number, unsigned integer notation. And if you write u, unsigned notation, so unsigned integer notation it will print. So unsigned integer. So but in what way you print? The value is same, that is nothing but address. So generally we need to print the addresses by using percentile p. Okay, so this is the address. So now how to access the pointer? So now how to declare the pointer? So int star, maybe r. So I am writing r. R is one pointer. Q, star q is one more pointer, and star p. So these are the pointer variables. For one variable only we can assign 3-4 pointers. We can assign 3-4 pointers per only one variable. So how to do? So here I am assigning like this. See, so r is equal to address of n1. So next time onwards, if I want to print these things, so how can I print? See, so this is normal. This is normally I am using. So now I want to use with pointers, by using because I gave my address r is equal to address of n1. So r is equal to address of n1. So the value of n1 is nothing but simply I can write, if I write star here, if I write star, what happens? Star n1. So what it is going to print? So if I write here instead of star n1, so if I write r, because r is nothing but what, where it is pointed, address of n1. So the pointer r, if I print, so what it is going to print. And same way, so r, if I print r, what happens? What is r? What is the thing? Both the things if I want to print. So what it will give? See, exactly this is the first one is by using normal method. By using pointers also same thing I got. See, the value of n1 is equal to 90. How? Because here star r is nothing but pointer variable. Okay, so here r is nothing but pointer variable. So star r is nothing but pointer. Once again, r is nothing but pointer variable I assigned. Pointer variable means it must and should represent a value. That value is nothing but this address. Always it is pointing to that address. So if I want to write star r, what is star r? The content of the location. The content of the location. Maybe it is n, or it is average, or it is result, or anything. So here star r is nothing but the content of the location. So for suppose after completion of this step, what you understand? So not only by using n1 and n2, we can access the address locations by using star r and r. This is the way. This is also one of the way. So same thing, if I write one more example I am showing here. See, so here these two things are star and hash. The star and address, if you write same as x. So because these are inverse to each other, star and address both together cancelled, and we got x only. So for suppose if you write a plus plus, also a is equal to a plus 1, also same, or star p is equal to star p plus 1, also same, or star p plus plus also same. So you can use, if you want to increment in any method you can use. For suppose n1, if I want to increment the n1 value, so how to increment n1 value in this? If I want to increment n1 value, the method, for suppose here before giving r star r plus plus, if I write like this, what happens? See, so the value of n1 is equal to changed, but 90 is not changed. So here star r plus plus. So if you put this entire thing in bracket, what happens? Star r plus plus. So first we assigned the value 90 to this thing, 90. So int n1 is equal to 90, int n1 is equal to 90, int star q p. So anything you can access. So that means q is equal to n1, address of n1, and p is equal to address of n1. Okay. So these all are address of n1. In this way also you can assign, or otherwise directly we can tell, instead of doing this thing, p is equal to r. P is equal to r. That's it. So that means what? P is equal to the address of n1 only. P is also n1 only. So here by using pointer variable we can dereference the values. See, the value of n1 is equal to %d star r. If you write star p also same. And if you want to print that address, the p also same. See, so 91. How? First statement also we got 91, because we changed the content. So where the content, in the sense, in that address what value is there, that value is incremented by 1. Maybe if you call that address, or if you call that value by using n1 also 91, or that address location is n1 only. Okay, so choice is yours. The content is, for suppose in this location, in 5C location, 90 is there. If you want to call by using n1 also okay, q also okay, p also okay. So in what way you want to access, that is your wish. So if I want to point to next location, so if I want to go to next location, so next location means, see, star plus r plus plus. Now what happened? Garbage values it will take. Okay, so star plus plus. So r, okay, star r and star r. So if I do like this, what happens? See, the value of n1 is equal to 90, very good, and BC. So this is n1, where it is located n1, that is in BC position, and the value of n1 is nothing but some location, some address. So we don't know what is that address. Okay, and after BC and it will go to 0. Next location it is somewhere it is pointing, because we incremented that value, we incremented that address. It is not pointing the same thing right now because we incremented that pointer. So pointer address is different, pointer content is different. So always. So for suppose if I print q, so q is nothing but same. It will take q also same. See, 90, and the value of n1 is 90. The address of n1 is nothing but this thing only. Both are same because q is pointed to address of n1. So I hope you have some clarity. So depends upon number of examples you got. So first see, p and q. There are two pointers, p and q. So before, something is there here. That is nothing but garbage value. Some garbage value is there in x. So now we are writing, there are two pointers are pointing, sir. P is pointed to x and q is also pointed to address of x. Both are pointing. P is also pointing address of x, q is also pointing address of x. So if x is equal to 4, then p is nothing but 4, q is nothing but 4, the content of p is nothing but 4, the content of q is also nothing but 4. So then x value is nothing but 4. All are 4. Now p, q, so this is 4 and x. So x is equal to x plus 3. If I write x is equal to x plus 3. So where it is going to change? In that address location, 4 plus 3. 4 plus 3 is nothing but 7. So now the content of p, pointer p, is nothing but 7. The content of pointer q is nothing but 7. And the content of x location is also 7. So now, so p, q, 7 is there already, we know. So star p is equal to 8. We are assigning a value to particular address, where what is that address? Star p. So you put some location, that is nothing but pointer variable. In that pointer variable, you put some value called 8. So then now what happened? P is 8, q is pointing to 8, and x is also 8, because in that particular address location we changed all these things. So now one more way. So 8 is there. So star address x is equal to star q plus star p. So what is the meaning? Star address. So previously we know. So star address is nothing but these two are going to cancel and x only remaining. So that means x is equal to star q plus star p. Star q is 8, star p is 8. Star q is representing 8. Star q representing 8. 8 plus 8, 16. So directly you got 16. So in x, 16 is coming. So like this also can. Next, p, q pointing to 16 and x is there. So x is equal to star p into, this is multiplication operator. Here star is nothing but, there is a gap between these two. There is a gap, one space is there. So star p star q. So this star is representing pointer, this star is representing pointer, but middle one is representing multiplication. So 16 into 16. 16 are 256. So that is the answer what you got. So this is the way how we are going to access the variables. So now So this is our one example I given. Now we will see how to declare pointer declaration and definition. So as like every topic how we are learning what are the syntax we can use. So to declare a pointer variable, the asterisk symbol is used, star is used, always star can be used, and along with the type specification. Type specification in the sense what? Which type of that thing. So type identifier. So the declaration is nothing but pointer declaration, type identifier. Do you know this thing previously? Now how to declare the pointer? Type star identifier. Type star identifier. So type star, if you write this one also correct. So for suppose int star. So here only I can write. Here only I can write int star p comma q. So that means what? P and q are pointer variables only. Now we declare two pointers. That is the meaning. Otherwise int star p comma star q. So this is also possible. So like this also you can declare. So both are same. Int star p q also possible. Int star p comma star q also possible. Or otherwise type. This is the actual syntax. The syntax for declaration is type. Type means integer, char, float, anything. Okay. So type space identifier name. So you can declare star identifier. Identifier name or name of the variable. You can directly write name of the variable. Okay. So this is the way how to declare. So one more way I want to show. This is the syntax, sir. So one more way I want to show. What is that? Int star p comma a. So that means what? This is the pointer, but this is normal variable. This is the normal variable. Okay. But so this is the wrong thing. For suppose if I want to declare num1 comma one more pointer x. So x is a pointer now. So now I want to declare these two things, x pointer and num1. So don't do this type of declaration. Int star x comma num1. So if you think like this, so the wrong. Why? Here x is also pointer variable and num also pointer. Both are pointers. So don't do this type of thing. Don't do this type of thing. So if you want to declare, so int star p comma a, like this you can declare. If you want to declare all the pointers at a time, so you can declare star p star q. So that is also possible. So if you want to declare int star p comma q, that is also possible. But this one is not possible. So if you want to declare like that. So for suppose one more thing. So int star p comma star q comma star m, so comma num1. So this is possible. So why? These are our pointer variables. This one is normal variable, normal identifier, normal. It is an integer type of data. That is also possible. But this one is not possible. So if you want to declare like this, in your mind you are thinking like this, and if you write like this, it is not correct. Okay. This notation is okay. Here this one also star and this one also star. Star means pointer. Okay. So now, so this is the example. So the definition. So there are different type of definitions you can use. Data declaration, type identifier, and type star identifier. So this is the first way. Char a, int n, float x. So these are the char a is equal to z, int n is equal to 15, float x is equal to 3.3. So like this you can declare normal variables. Then pointers how to declare? Char star p or char star p, it is a pointer. Int star q, it is also pointer. Float star r, it is also pointer. So like this you can declare the pointers. So then how to use? So hash include std what it is int main void. So int a int star ptr, one pointer I am taking, one variable, one pointer. So here system.cls clr this is nothing but clr. So a is equal to 4, the value of a is nothing but 4. Then ptr is equal to address of a. If you assign this address of a to this thing, so printf percentage d and percentage p. So a value you can print and address of a you print. So print percentage d percentage p. So star ptr and ptr. This represent a represent star ptr and address of a represent ptr. So like this you can. So like this both the ways you can use. So choice is yours. So previously I shown this example. See, this is the example. So represent same thing. This one only. So next here, yes, tell to her sir. So somebody is doing disturbance. Hindu, K Hindu. ఆ కే హిందూకి ఒకసారి కాల్ చేసి చెప్పండి, ఆమె సినిమా చూస్తుంది, మనం చూడాల్సిన అవసరం లేదు. ఓకే. సో నెక్స్ట్, సో డిక్లరేషన్ వర్సెస్ రీడైరెక్షన్. ఓకే, డిక్లరేషన్ వర్సెస్ redirection. So the asterisk operator can be used in two different contexts. So one is for declaration, for redirection. So for the declaration purpose we can use. And when asterisk is used for declaration, it is associated with a type. So must and should you need to mention with a type. Okay. And type star int star ptr will declare in an integer pointer. So this will be declared in integer pointer. Okay, so you can do like that also. So when asterisk is used for redirection, it is associated with a pointer variable to get the data value of the variable whose address is not stored in the pointer. So sum is equal star a ptr and b ptr. So there are, if you want to access two variables at a time, if you want to add two pointers at a time, pointer a ptr, pointer b ptr also you can use. You need not to declare like ptr also. You can use x, y, dog, cat, so any name you can put, but in what way you are representing the value, only the meaning. Okay. So initialization of pointer variables, how to initialize. So like every other object in C, pointer must be initialized before they can be used. We know that thing. So without initialization, how we are going to use? So like variables without initialization, pointers will also have unknown garbage value. Not always they are going to point to some other X person. So when the program starts, all unutilized pointers, so uninitialized pointers, will hold some unknown addresses which are pointing to some unknown values. We don't know where they are going to point. Okay, so that is the first initialization. So next, pointer to pointer, how pointers can represent like a pointer, one more pointer. I hope you understand what is this thing. So I want to give one example here. So by using functions, you know swapping previously, swapping program. So what is meant by swapping, sir? Slash swapping. Swapping means exchanging of data. For suppose int num1 comma num2. So there are two numbers. So must and should require one temporary variable. So temp. Must and should require one temporary variable. So num1 is equal to maybe 100. So num2 is maybe 40. So now here I am going to write, see, printf before swapping. before swapping means what? Just exchanging the values. Before swapping, this program number of times you can use. So algorithms and everywhere you can use this program. So before swapping, num1 is equal to percentage d, comma num2 is equal to percentage d. Here address of num1 comma num2. Okay. So num1 comma num2. So here I am going to print these two values. So after swapping, what happened? After swapping, num1 is equal to percentage d, num2 is equal to percentage d. So what is the swapping here doing? So here I am taking temp is equal to num1. So num1 is equal to num2. Then num2 is equal to temp. Okay, this is the way how we are going to swap. So here we are duplicating. So one duplicate variable, one temporary variable you are taking. So into that temporary variable you are copying the content of num1, and after that num2 is copied into num1 and num2 is copied into temp. So this is the normal way. Second unit only I think we learn. So because without this thing I can't tell searching, sorting, that things. So searching, sorting we already completed, means this program already we know. So once this program is done, executed, see, before swapping num1 is equal to 100, num2 is equal to 40. After swapping, what happened? Num1 is equal to 40, num2 is equal to 100. So same thing how we are going to do with the pointers. How we are going to do with the pointers. So to do with pointers, so here then what is the greatness of, if once again if you are using with the temp, what is the greatness? So there is no greatness. So if you use same thing, so for that here I am going to declare int star pointer for num1 I called star pn1. Okay, star pn1, convenient name. For me it is a convenient name, star pn2. So there are two pointers I am using. One is int star pn1 and int star pn2. So here what I am doing, so once this is done, this way I don't want to do. Normal way I don't want to do. So I want to first star pn1 is equal to, so address of n1. Okay, so I am taking the address of n1 is nothing but star pn1. So here the star pn1 is equal to address of n1. Done. So that means what? If I do anything here, star pn1, so automatically n1 value is going to be changed. So now here the pn1 content is copied into somewhere. The pn1 content is going to be copied into somewhere. I want to copy that location into somewhere. So where is that location? For suppose pn1 is exchanged with the addresses I want to change. Only within the addresses only I want to change my values. So already pn1 and pn2 are having some values. So I want to swap them without using anything, without using any temporary variable. So how to do? So by using pointers it is possible. So once you understand that concept, we are able to do that program. We will see. So first, so pointers to pointers. In C it is possible, it is okay, possible to use pointers, that pointers to pointers. So that is, we can have pointers to pointing, a pointer again, once again it is pointing. So the following figure demonstrate this two level indirection. So that one what you call two levels. So int a is nothing but only one thing. So int star p int star q into star q. So how? So for suppose Q is pointing to one pointer P is pointing to 58. So that means A. So here A is equal to 58, P is equal to address of A, Q is equal to address of P. So that's why here star star Q is nothing but what? Pointer with the pointer. So pointer only pointing to another pointer. So that means what? This is 2,34,560 is nothing but Q. Q pointing location, and P pointing location is 2,87,650. This is assuming only. We need not to by heart this thing, and we need not to write in exam. So but concept must and should be you need to understand. So actually here this is the address. The Q is stored in 3,97,870. This is the Q location, and P location is 2,34,560. So but this Q location points a location address that is nothing but 2,87,650. So this location address is pointed with one more variable called 2,87,650. So this 2,87,650 is loaded into this thing, and this address location, the P address location, is loaded into this thing. So now double time, not one time. It is a two layered. So first layer means what? Only this part. So two layer in the sense what? Pointer with the pointer. So this is the way printf %d a. So that means 3 decimal places which it will give, and printf %d, that is star p, printf %3d star q, star star q, star star in the sense what? Because it is a pointer to pointer location it is showing. Next, R is representing Q, or R is pointing to Q address, Q is pointing to P address, P is pointing to A address. That is nothing but using pointers to pointers in 3 levels. Now this example gives the 3 levels. So int star P, int star star Q, int star 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 R. So that means what? R can point to Q, Q point to P, P point to A. So this is the way how we are going to use that all the things. But our answer is same. Same value we can represent by using in this these many layers. So now we need to go to this concept, that is pointer to void. So what is the void? So here generally it is called a null pointer, always we can use. A pointer is to void is a generic type that is not associated with any reference type. That means what? It is not integer, it is not a float, it is not a character type. So only it is a generic type. As like always we are using generic medicine. So like that, this is the general type. Paracetamol, it is a generic medicine. Yes, we are always using. So for a lot of symptoms purpose, paracetamol is used. But some medicines are used specifically. So same way, it is not an integer, it is not a float, it is not a character, but it is a pointer. It points to some reference. So that type is not not the address of a character or an integer or floating point or any other type. So it is compatible for assignment purpose only with all other types. If you want to assign to any other one, it can be accessed. So a pointer of any reference type can be assigned to a pointer void type, and a pointer to void type can be assigned to any reference type. So both ways it is possible because it is a void pointer. So how to use? So int a of 20, so char a of, so char c of a. So this is the character type, this is the integer type. Void star ptr. So void means what? It is not a integer, it is not a float, it is not a something. So ptr is equal to address of a you can use. Same ptr you can use for address of c. That means what? One time you assigned with integer type of value, one time you assigned with character type of value. So one time you are using character type, one time you are using integer type. Both ways are it is possible. That is the example it is giving. So now how we are going to use arrays and pointers together. So how arrays can be accessed with the pointer, and what is the concept behind array and pointer. So you know the one dimensional array, previously we saw arrays are one dimensional, two dimensional and multi-dimensional. So one dimensional in the sense int a of some size, maybe 10. Two dimensional in the sense maybe int x of 3 by 4. This is two dimensional. So multi-dimensional in the sense int m of or m or z something. So int z of so 1 and 2, so on 8. Okay. So like this you can declare the variables. So this is one dimensional array, this is two dimensional array, this is multi-dimensional array. So we can access the elements and everything. But if I declare any array like this, a of 0, so some value, a of 1, some value, so a of 2, some value, a of 3, some value, and a of 4, some value. But these all are associated with something called, see, a of 0, a of 1, a of 2, a of 3, a of 4. So it is an array of 5. So but the first element address only it will take. So how it will take? The first address element. So for suppose if I declare int a of 5. So that means what? It is having 5 elements. These are my addresses. I have 5 elements, a of 0 and a of 1, a of 2, then a of 3 and a of 4. So this may be at the location of 2,87,500. This must and should be 2,87,502 because integer can occupy 2 bytes. That's why. Next, this is 2,87,504. This is 504, and this is 2,87,506. This is 2,87,508. These are the address locations. Maybe contents we are not bothering. The contents are 6, 20, minus 5, 8, 24. Some values are also there inside. So this is my array. So how to access this array? By using a pointer. So I can declare a pointer int star p. I declare a pointer int star p. So here p is equal to, so here address of a. If I give address of a, so what is the meaning of this address of a? Means this one, 2,87,500. So this 2,87,500 is assigned to this p. The p location is content of the content. The content of p location is nothing but 2,87,500. Now this is the address. So if I want to access this element, how I can access? Directly p plus 2. P plus 2 is nothing but what? This location. I am talking about a of 1. So p plus 4 is nothing but what? I am talking about a2. So p plus 6 is this one. P plus 8 is this one. So every time depends upon the data type. For suppose if it is an integer, 2222 incremented. If it is a floating point number, 444 it will increment. If it is a character, 111 it will increment it. Depends upon the size. This is 1 byte or 2 byte or 4 byte. So it depends upon the bytes. So it is taking the value. So same explanation here. See, a is same as address of a0. A and address of a0 both are same. Star a is nothing but a of 0. The content. Okay, star a is nothing but a of 0. So both are equal. So if I access a A is nothing but it is a pointer here. A is nothing but a pointer. If I talk about A, that is nothing but a pointer. See, for example, int A of 4, 2, comma, 4, comma, 3, comma, 1. This is an array already assigned. So printf the first location address. What is the first location address in this? Star p and star p. If I print A also same. If I print address of A0 also same. See, first location address. This is the first location address. If I print A is also same because it is a pointer, and address of A is also same. Both are same. Next, so if I want to print the location value star A, if I print star A also same, or if I print A0, A of 0 is also same. Both are same. So that means what? You need not to declare one more pointer extra here. So here A is only the pointer. You need not to declare anything. That means what is that? Array of pointers. That one pointer array. You see, pointer arithmetic and pointer array you can do like this. So array and pointers. How to access array and pointers means if I declare A of 0 or A of 10, so A is nothing but my pointer variable. You need not to, once again you need not to declare and you need not to use. Automatically it is there in your program. Okay, this is one of the great topic in C. So by using this thing only we can design a lot of gaming concepts and algorithms and everything, linked lists. So when you are declaring linked list and everything, this is very very useful concept. Okay, this program and everything. So next, the first location, if you want to print A value you can print, and address of A0 both are same. And the second, the first location values if you want to print star A if you print, and A of 0 if you want to print, both the things are same. So next, pointer arithmetic and arrays. How these two things are going to use. So how the pointers are going to participate in addition, subtraction, multiplication, division and everything. See, so the basic indexing you can use like a pointer. So how? A plus 1. If A is a pointer variable, A plus 1 is constant pointing to the second element. A plus 1 is second element, A plus 2 is third element, A plus 4 is fourth element, like that. So A plus 1, A plus 2, A plus 3, A plus 4. So 2, 4, 6, 8, so some 22. So these are the values. What I am having, these are the values. So P minus 1, P plus 1, P plus 2, P plus 3. So here P minus 1 is nothing but what? Some pointer P is pointing to first element, that is 4. So P minus 1 means I am talking about the before element, because I am talking about address. Here I am not talking about any value, I am talking about the address. That's why P is pointing to first element or second element in the array. If I want to talk about the first element in the array, simply I want to P minus 1, pointer minus 1 I can do. So if I want to talk about the next element, P plus 1. So if I want to talk about after next two elements, P plus 3. Okay. So this is the indirection operator, how to use. A of 0 or star A plus 0 also you can use. A of 1 or star A plus 1 also you can use. So like this, these two are exchangeable. Previously you used this thing, now we can use this thing also. Here also same, A plus 1, A plus 2, A plus 3, A plus 4 also we can use. These are the content. This is the program what you have. Same, this entire explanation given for this program. So what is this? So here an array is there, one dimensional array. The length of the array is 5. That means 5 elements you can store. 2, 4, 6, 8 and 22. So int star ptr, I am declaring a variable called star ptr. So ptr is equal to address of a1. I am taking address of a1. I am not assigning to a0. I am talking about address of a1. So printing an array, complete array, if I want to print a0, a1, a2, a3, a4, like that you can print. If you want to print by using pointer arithmetic, simply ptr minus 1, that is 0, PTR plus 0, that is first element, and PTR plus 1, PTR plus 2, PTR plus 3. So like this you can print. Same way, printing array elements using pointer arithmetic also you can. So that means star A plus 0, A plus 0. A is pointing to A only, plus 0 means same address. So A of 0, A of 1, A of 2, A of 3, A of 4. So like this also you can print. In both ways, in all three ways it is same. We are printing array. Next, so self-referential structure. So self-referential, how one thing is pointing to self, so itself how it is going to point to same thing. So self-referential structure holds one or more pointers. Okay, pointer only points itself, the same structure type as a their member. So here we are declaring a node. Yesterday for this concept is somewhat difficult to A section, because B section already I completed structures, but for A section I can't completed structures concept. That's why this is somewhat I want to speak about later, this thing structures. When I am talking about structure, self-referential structure, I will simple that one also, but one link is representing another one is representing another. So like this what, so node 1, node 2, node 3, so it is nothing but linked list. So there is a linked list program in a fifth unit actually. So some memory allocation functions and everything we have. So go through this thing. So in tomorrow's class, so I want to finish this pointers. So Monday I think you have 2 hours for A section. So at that moment I want to complete structures. So once structures completed, so if you practice only, you got this problem. Pointers concept, without practicing you can't. Okay? Files is the easiest concept. 5th unit is the files concept, but this is the easiest one among all. This is as like a theory. In first unit how you have theory, same thing you have theory for 5th one. Okay? So but algorithms are there. In 5th unit we have I think 7 algorithms are there, 7 programs, some bigger programs are there. So we need to concentrate on them. So that's why syllabus completion is not a task, but how much you achieved or how much you are able to understand, that is only the task. So you execute today. I will send this pointers thing. So you execute and express your doubts in WhatsApp and somewhere, okay, or phone call. So I can clarify your doubts and everything. First go through this thing and try to understand and run the programs. First you need to run these programs in your mobile. So then you are able to understand the concept properly. Okay. So this is more enough today. So if I conclude automatically, I can complete 5th unit first part also. But in online I don't want to talk about functions. The pointers also once again I will repeat somewhat, not entire thing. 1 or 2 programs I will explain in offline also. Okay. So because pointers is a very excellent topic in C, because C is that much famous due to pointers only. So this is a number of times I am telling. So without knowing pointers, nothing you know in C. So that is what you need to understand. Okay, thank you. And tomorrow in the sense next we will meet once again. So maybe if it is possible, tomorrow also I will put a message. So I will take half an hour class. I will explain 2-3 programs related to pointers. Okay. So first go through these examples, and you must and should differentiate between what is the real address and pointer address. Okay. What is the pointer variable and pointer constant. So what is meant by pointer content and how it can be used in arrays. So once you have this clear cut idea, then pointers is very easy in future scope and future usage purpose. Okay, thank you. So you can leave the meeting.